Properties of rational exponents. So before we start, let's review for a second. Rational just means fraction. So we are basically talking about how to work with fractions in our exponents. So here we have a table of all of our properties for exponents. You should recognize these because these are the same ones that you learned when you did integer exponents. When you are multiplying same bases together, you're going to add their exponents and keep the base. So 5 to the 1/2 times 5 to the 3/2, add your two exponents together, and you're going to get your simplified version. If you have a power and a power raised to one another, so 3 to the 5/2 all squared, you're actually going to multiply their exponents together. Now, this is one that may be different. You're going to, if you have two things multiplied raised to an exponent, that means the individuals are both raised to that exponent as well. So 16 times 9 to the 1/2 means you have 16 to the half times 9 to the half as well. Negative exponents, we don't like negatives as far as simplifying, so don't leave negatives in your simplified version. If you have a negative exponent, you need to keep going. The way you work with this is this is really a fraction. So with negative exponents, they're not happy in the place of the fraction that they're at. So if they are in the numerator and negative, we're going to take the thing that's attached and move it down. If they're already in the denominator, you're going to move it up. Zero exponents, well, anything to the zero is a 1. Even anything like a million raised to a 0 power is going to equal to a 1. That is the rule for zero exponents. When you have division, you have the same base divided with exponents. You're going to subtract their exponents from each other in the order of numerator minus denominator. If this ends up being negative, you're going to place the result in the denominator of your fraction. Last thing, power of a fraction. So kind of like this one here, when you have two things multiplied raised to a power, same thing here. If you have two things divided to an exponent, both numerator and denominator get the same exponent. So here's your example. 27 over 64 to the 1/3 means I'm going to take 27 to the 1/3 over 64 to the 1/3 as well, and then keep simplifying if possible. So let's try a few of these. So example 1, simplify 7 to the 1/4 times 7 to the 1/2. So we are multiplying with the same base. So since we are multiplying, that means what we're going to do with these exponents is actually add them. So we're going to have a 7 to the 1/4 plus 1/2 power. Multiplying means add your exponents together. So I'm going to do this little piece on the side. So 1 over 4 plus 1 over 2. Remember, adding fractions, you need common denominators. So I'm going to multiply by 2 over 2. So this becomes 2 over 4. So 1 over 4 plus 2 over 4 makes 3 over 4. So your simplified version with this is 7 to the 3 over 4 power. Let's work with some more rules. So example 2, 6 to the 1/2 times 4 to the 1/3 all squared. So I can't do anything inside here because 6 and 4 are not the same base. So I can't add these like I did a minute ago with my 7s. But I do have a rule that since I have powers raised to another power, I'm going to use this and multiply to my existing ones. So it's 6 to the 1/2 times the 2 on the outside, multiplied by 4 to the 1/3 times the 2 on the outside. Then let's simplify our exponents. So 1/2 times 2 is 2 over 2. Well, 6 to the 2 over 2 is 6 to the 1st, which is really just a 6. Then 4 to the 1/3 times 2. Well, 1/3 times 2 makes 2/3, which that's not going to simplify any further. So your final answer is 6 times 4 to the 2/3 power. Because these are not the same base, this is as far as you can simplify. Example 3, 4 to the 5th times 3 to the 5th. So again, these are not the same base, so we can't really work much with this. So what we're going to do is we're going to take that negative 1/5 on the outside and kind of distribute it to the other exponents. So 4 to the 5 times negative 1/5 times 3 to the 5th times negative 1/5. Let's clean up our exponents. 5 times negative 1/5, so this is going to be 4 to the negative 5/5 power, times 3 to the negative 5/5 power. So we have 4 to the negative 1 times 3 to the negative 1. Well, negative exponents mean you're going to change their position in the fraction. So these are actually all over 1. So since this has a negative exponent, since he's in the numerator, we're going to drop him. This also has a negative exponent, he's going to drop as well. So in the denominator now, we have 4 to the positive 1 power times 3 to the positive 1 power. And in the numerator, we have a 1 that's left over as a placeholder. So now that these exponents are positive, they're easier to work with. 4 to the first is just a 4. 3 to the first is just a 3. So I have 4 times 3 in the denominator, so 4 times 3 makes 12. So this is the most simplified that your expression will be. Alrighty, 5 over 5 to the 1/3. So same base, but now we're dividing. So the rule for division is you're going to subtract your exponents. So if there is not an exponent shown, we assume that it is a 1. So this is really 5 to the first minus 1/3. Numerator minus denominator. That's the order in which you subtract. So I'm going to do this subtraction on the side. 1/1 minus 1/3. I need a common denominator, so I'm going to multiply by 3/3. So this becomes 3/3 minus 1/3. 3 minus 1 makes this 2/3. So what this division turns into is 5 to the 2/3 power. Let's get into the more complicated examples. So I have 42 to the 1/3 divided by 6 to the 1/3, all to the negative 2 power. So I know that these aren't the same base, but I do see that they have the same exponent. So I can actually take that exponent and put it back on the outside of a set of parentheses. Then of course I still have all of this to the negative 2. And here's why I did this. I know that 42 divided by 6 is a 7, so that's going to make life a little bit easier. There's not one way to do all of these problems. You can do them multiple ways. We can do this like we did the one in the beginning and distribute in this negative 2 to both exponents. 42 over 6 makes 7 to the 1/3, all to the negative 2. It looks a little bit nicer than a fraction. So now we're going to take this negative 2 and multiply in according to my rules. Power to a power means you're going to multiply your exponents. So 7 to the 1/3 times negative 2. This is going to make 7 to the negative 2/3 power. Now again, we don't want to leave negatives in our exponents. So this is really over 1. So since this is a negative exponent, we're going to drop him in the fraction. So we're going to have 7 to the positive 2/3 in the denominator. And since there is nothing left in the numerator, we put a 1 as a placeholder. And this is as simplified as your example will be. Example 6. 2 times 8 to the 1/5 plus 10 times 8 to the 1/5. So don't forget that we can change exponents into radical equations. So what this really is this 8 to the 1/5, if we remember, the 5 is the index of your radical, and the numerator is your exponent on the inside. So this 8 to the 1/5 is actually the 5th root of 8. So what you really have here is 2 times the 5th root of 8 plus 10 times the 5th root of 8. This is actually adding like terms because you have the same radical on both terms. So when you see you have this guy added to the same, you're really just adding up like terms. So we can skip this whole step here and just go to the addition. So 2 plus 10 makes 12, 8 to the 1/5 power. It doesn't matter how you write it. You could have also written it as 12 times the 5th root of 8. Those are both equivalent expressions. It just depends on how the question wants it answered. So addition, make sure you have the same like term multiplied. This one is similar. So example 7, 5 times 2 to the 1/3 minus 54 to the 1/3. Well, these are not the same this time. So I'm going to have to see if I can maybe finagle this to make them the same. 2 looks pretty small, so I'm going to hold off on that. Now, 54 to the 1/3, I'm going to change that into its radical form. So this is your index. So it's actually a cube root of 54 to the first power, which is just 54. Now I'm going to simplify this 54 down into 9 times 6, 9 into 3 times 3, 6 into 3 times 2. So because it's a cube root, I want groups of 3. So this is really 3 times the cube root of 2. Now, I don't have radicals, I have fractions. So I'm going to change this back into its fractional form. So this is really 3 times 2. This is a 1 as an exponent, that's your numerator. Over the denominator is the index, so a 3. So what this original question actually is asking is 5 times 2 to the 1/3 minus, we simplified the second term into 3 times 2 to the 1/3. So now we have a pair of like terms. So 5 minus 3 makes 2, 2 to the 1/3. Simplify your fractional exponents, make them into radicals, and simplify. Now let's try one that has a bunch of multiplication and radicals and things that are going on. So we have square root of c times the cube root of c to the 5th all over the square root of 15 c to the 4th. It's a lot going on. So let's try to simplify just the numerator first. Now we cannot use our multiplication property of radicals because this is a square root and this is a cube root. But what I can do is I can change them into exponent form and maybe work with exponent rules instead. So let's work on getting only the numerator as simple as possible. We have square root of c, so the exponent is a 1 and the index is a 2. So this is going to be c to the 1/2 power times. Then we have the cube root of c to the 5th. Well, the exponent is a 5 and the index is a 3. This is going to be c to the 5/3. So since these are the same base multiplied, the rule says I can add my exponents together. So this is going to turn into c to the 1/2 plus 5/3. So let's do this fraction addition over here on the side. So 1/2 plus 5/3. I need a common denominator, so I'm going to multiply the 5/3 times 2 over 2 to make it the denominator into a 6. And 3 over 3 on the 1/2 to make the denominator 6. So 3 over 6 plus 10 over 6, which makes 13 over 6. So your numerator is now c to the 13 over 6 power. So we're going to hold off on that. So this is the numerator. Now let's go work with the denominator. So square root of 15c to the 4th. Changing this guy over isn't as easy as the other one because they both don't have the same exponent. 15 has an exponent of 1 and c to the 4th has an exponent of, well, 4. So we're actually going to have to take this and use the multiplication property to split this up. 15 and c to the 4th are being multiplied together. So this is actually square root of 15 times the square root of c to the 4th. Now that these are broken up, I can change them both into the exponent form. So this is going to be an exponent of a 1, index of a 2, 15 to the 1/2 times exponent of 4, index of 2, c to the 4 over 2. Now, 4 over 2 can actually simplify. So that's 15 to the 1/2 times 4 over 2 is just a 2, so c squared. This is your new denominator. So let's put all of our fraction back together. So my numerator came out to be c to the 13 over 6, and my new denominator came out to be 15 to the 1/2 times c squared. So let's get this guy simplified. So I see that I have the same base, c and c, divided, and according to my rules, when you divide, you're going to subtract the exponents. So 13 over 6 minus 2 over 1. So again, let's do this subtraction on the side. 13 over 6 minus 2 over 1. So I'm going to multiply 2 over 1 by 6 over 6. 6 times 2 makes 12. 13 minus 12 makes a 1 over 6. So we have c to the 1 over 6 in the numerator over 15 to the 1/2. And because c and 15 are not the same base, this is as simplified as you can get. Let's try the last one. So example 9, we're going to simplify this gigantic fraction. So I have 18 w to the 1/3 v to the 5/4 over 27 w to the negative 4/3 v to the 1/2. So we don't want to change these into radicals because radicals are a lot more strict than exponents are. So we're going to leave these the way they are. I'm going to take this guy in pieces. So I'm going to take this set of numbers first. 18 over 27. That's just plain old numbers. Let's see if I can simplify 18 and 27. I know I can divide them both by a 9. 18 divided by 9 makes 2. 27 divided by 9 makes a 3. So there's the first piece of my simplified version. Now the second thing I'm going to try to simplify are my w's. I have a w in the numerator and a w in the denominator. So a w to the 1/3 over w to the negative 4/3. Well, according to my rules of exponents, if I have division, I'm going to subtract. So this is w to the 1/3 minus negative 4/3. So we're going to complete this on the side. 1/3. Now, minus a negative is actually adding. So it's actually 1/3 plus 4/3. Well, my denominators are already the same, so 1 plus 4 makes 5 over 3. So this little piece simplifies down to w to the 5/3. And the last little piece I'm going to look at are my v's. So my v's, v to the 5/4 over v to the 1/2. Again, division says you are going to subtract your exponents. So 5/4 minus a 1/2. So I'm going to take this and do it over here. 5 over 4 minus 1 over 2. I need common denominators to complete this. So multiply by 2 over 2 to get a common denominator of a 4. 5 minus 2 makes 3 over 4. So my v section is equal to v to the 3/4. So let's put it all back together. Now, you're going to have 2 over 3 from the first part we did. Since this v to the 5/3 ended up with a positive exponent, he will be in the numerator. If it ends up with a negative exponent, put it in the bottom as positive. V to the 3/4 is also positive, so he's okay to stay in the numerator. And this is as simple as you're going to be able to go, because v and w are different bases, so you can't simplify this any further.